Good day, viewers. My name is Agali Belinda Chizoba, taking on the subject chemistry and the topic second law of Faraday. By the end of this lesson, students should be able to state Faraday's second law of electrolysis and solve calculations involving Faraday's laws of electrolysis. Michael Faraday, after studying the effects of electricity on salt solutions connected in series, came up with his second law. Faraday's second law of electrolysis states that when the same quantity of electricity is passed through different electrolytes arranged in series, the amount in moles of each element liberated is inversely proportional to the charge on its ion. Mathematically, we can say that N varies inversely as C. That is, NC is equal to constant, where N is the amount in moles of the element liberated and C is the charge on the ion. Thus, if the same quantity of electricity in coulombs is passed through three different electrolytes in series, the various amounts of elements N1, N2, N3 liberated or deposited will be related to the charges C1, C2, and C3 and their ions by the expression N1C1 is equal to N2C2 is equal to N3C3. Equation 1. And since amount N is equal to M over M, equation 1 can be rewritten as M over M1C1 is equal to M over M2C2 is equal to M over M3C3. That is equation 2. Equation 2 gives the general mathematical formula for the second law of electrolysis. Solve the examples. A voltmeter containing silver trioxonitrate solution was connected in series to another voltmeter containing copper 2 tetraoxosulfate 6 solution when a current of 0.200 amperes was passed through the solutions. 0.780 grams of silver was deposited. Calculate the A, mass of copper that will be deposited in the copper voltmeter. B, quantity of electricity used in the time of flow. Solution. Since M over M1C1 is equal to M over M2C2 and silver is a univalent atom while copper is a divalent atom, substituting the formulas, the options we have inside the formula, that means that 0.780 divided by 108 times 1 is equal to M over 63.5 times 2. Making M such a formula, we have 7.22 times 10 raised to the power minus 3 divided by 0.0315, which will give us 0.229 grams of copper. Then for the B part, since 108 uses 96,500 coulombs, that means that 0.780 will use 96,500 times 0.780 divided by 108 is equal to 697 coulombs. And since Q is equal to I times T, we can make this sort of formula and find our time in seconds. And it gives us 3,485 seconds or 58.1 minutes. When brine, which is concentrated sodium chloride solution, was electrolyzed using carbon electrodes, 1.5 dm³ of chlorine was evolved at STP. Calculate the mass of sodium hydroxide produced at the same time. Molar volume of any gas at STP is 22.4 dm³, while the molar mass of sodium hydroxide is 40 grams per mole. Solution. 22.4 dm³ contains 1 mole. That means that 1.5 dm³ will contain 1 times 1.5 divided by 22.4, which is 0.0670 mole per dm³. Since this is in amount in moles, that means 0.0670 multiplied by 2 is equal to M over 40 multiplied by 1. Making M straight of formula, we have 0.0670 times 2 times 40 to give us 5.36 grams of sodium hydroxide. Another example, a quantity of electricity liberates 3.6 grams of silver from its salt. What mass of aluminium will be liberated from its salt by the same quantity of electricity? The molar mass of aluminium is 27, while that of silver is 108. Since aluminum is trivalent and silver is monovalent, we can use this formula and substitute 3.6 grams of silver divided by the molar mass of silver, which is 108, multiplied by 1, since silver is monovalent, can be equal to m over 27 times 3, since aluminum is trivalent. Therefore, 0.3033 can be equal to 3m over 27. Making a substitute of formula, our answer should be 0.3 gram. A copper and silver voltmeter is connected together in series. If a current of 4 amperes flows for 1 hour, calculate the masses of copper and silver deposited. The molar mass of copper is 64, while that of silver is 108. Solution. Since silver is univalent and copper is divalent, to calculate the mass of silver deposited, we are using the formula that we used in the first law of Faraday, which is IT over CF is equal to M over M. And making M straight of formula, we can say that M is equal to I times T times M all over CF. I is equal to 4 amperes times 1 times 60 times 60, since it's 1 hour, multiplied by 108, divided by 1 times 96,500. And at the end of the day, we have 16.1 gram of silver. Then for the mass of copper, since they are connected in series, we can now use M over M1 C1 is equal to M over N2 C2. We have gotten the mass of silver to be 16.1 divided by 108 times 1 is equal to M over 64 times 2. To make a straight of formula, we have 2M is equal to 9.4, while M is equal to 9.54 divided by 2 to give us 5.8 gram. In an electrolytic experiment, 0.6 F of electricity is passed via a solution containing silver nitrate and aluminum sulfate connected in series. Calculate the number of moles of metals deposited in each case. We have written the equation for the reaction, which is silver plus electron to give us silver solid, and aluminum plus 3 electrons to give us aluminum solid. If 1 Faraday liberates 1 mole of silver, that means that 0.6 Faradays will liberate 1 times 0.6 divided by 1 to give us 0.6 moles of silver. Remember that from second law of Faraday, we have that N1C1 is equal to N2C2. Our N1 in this case is 0.6 multiplied by 1 equal to N2 multiplied by 3, since aluminum is tetravalent. That means that N2 will be equal to 0.6 times 1 divided by 3 to give us 0.2 moles of aluminum. Calculate the volume of oxygen measured at STP liberated when copper sulfate was electrolyzed using platinum electrodes. If 3.5 grams of copper is deposited at the cathode, your answer should be in 3 significant figures. Copper has a molar mass of 64. Molar volume at STP is 22.4 dm3. Using N1C1 is equal to N2C2. And we know that copper is divalent, while oxygen is using 4 Faradays. We can say that 3.65 grams of copper divided by the molar mass of copper, which is 64, multiplied by 2 is equal to N2 times 4. Our N2 will be equal to 0.114 divided by 4 to give us 0.0285 mole of oxygen. And since 1 mole occupies 22.4 dm3, that means that 0.0285 moles will occupy 22.4 multiplied by 0.0285 divided by 1 to give us 0.639 dm3 or 639 centimeter cube of oxygen. Calculate the mass of silver deposited by electrolysis from a solution of silver triisonitrate 5 placed in series with a copper tetraoxosulfate 6 solution when 0.08 grams of copper are deposited on the copper plate. The molar mass of copper is 64, that of silver is 108, and Faraday's constant is 96,500 coulombs per mole. Solution. Since copper is divalent and silver is monovalent, we can use M over M1C1 is equal to M over M2C2. Since we are looking for the mass of silver, we call that one M2 and make use of formula and get 0.27 gram. In the electrolysis of a solution of copper 2 tetraiodosulfate 6 using copper electrodes, a current of 0.3 amperes flows for 20 minutes. The initial mass of the anode was 20.90 gram. The initial mass of the cathode was 25.00 gram. Calculate the final mass of the anode and cathode. Solution: equation for the reaction. At the anode, copper metal will dissolve to form copper 2 ion, while at the cathode, copper 2 ion will accept electron to form a copper solid. Note that at the anode there is a decrease in mass and there is an increase in mass at the cathode. And since Q is equal to I times T, that means that 0.3 amperes multiplied by 20 by 60 will give us 360 coulombs. And since 1 mole of copper is equal to 64 grams and needs 2 times 96,500 coulombs, then 360 coulombs will liberate 360 times 64 divided by 2 times 96,500, which will give us 0.12 gram of copper. Final mass at the anode will be 20.90 minus, since the anode is going to reduce, to give us 20.78 gram, while the final mass at the cathode is 25.00 plus 0.12, since cathode is going to increase, to give us 25.12 gram. A metal of relative atomic mass of 27 was deposited by electrolysis. If 0.176 gram of the metal was deposited on the cathode, when a current of 0.15 amperes flows for 3.5 hours, what is the charge on the cathode of the metal? Faraday's constant is equal to 96,500 coulombs. Solution: Q is equal to I times T, and since we are given 0.15 amperes for 3.5 hours, we have 0.15 multiplied by 210 times 60 to give us 1,890 coulombs. If 1,890 coulombs liberates 0.176 gram of the metal, then 96,500 will liberate 0.176 times 96,500 divided by 1,890, which will give us 8.986 gram. 1 mole of electron of metal is equal to 1 F is equal to 96,500 C is equal to 8.986. 1 gram of metal produces 1 divided by 8.986. Therefore, 27 grams will produce 1 divided by 8.986 times 27, which is equal to 3F. The charge on the metal is plus 3. During the electrolysis of copper 2 tetraiodosulfate 6 solution using platinum electrodes, 0.16 gram of copper was deposited on the cathode. Calculate the volume of oxygen gas liberated at STP. Copper is 64 grams. Faraday's constant is 96,500 coulombs. 1 molar volume at STP is 22.4 dm³. Solution: copper is a divalent metal, while oxygen gas uses 4 Faradays. Using M over M1C1 is equal to M over M2C2. That means that 0.16 gram of copper divided by 64 times 2 is equal to M2 over 32 times 4. This means that 0.05 times 32 is equal to 4M2. Our M2 will be equal to 0.16 divided by 4 to give us 0.04 gram. Since 32 gram of oxygen occupies 22.4 dm³, then 0.04 gram of oxygen will occupy 22.4 times 0.04 divided by 32 to give us 0.028 dm³ at STP. You have solved so many problems, and you can use this to evaluate yourself. A zinc and copper voltammeters were connected together in series. If a current of 0.25 amperes flows for 10 minutes, calculate the masses of zinc and copper deposited. They are giving you the molar mass of zinc, molar mass of copper, and then Faraday's constant. You can calculate the quantity of electricity used. Find the mass of zinc, either zinc or copper deposited, and then substitute in m over m1 C1 is equal to m over m2 C2 to calculate the other gram of the metal. Number 2, in the electrolysis of a solution of copper 2 tetrahydrosulfate 6 solution using copper electrodes, a current of 0.15 amperes flows for 3.5 hours. If the initial mass of the anode and the cathode was 40.60 gram and 45.20 gram respectively, calculate the final mass of the anode and the cathode. Remember, the anode reduces while the cathode increases. When you get the mass liberated, you subtract for the anode and then add for the cathode. Number 3, a direct current of 0.5 amperes flows for 50 minutes through 3 cells connected in series. The cells contain solutions of silver trihydrogenate 5, copper 2 tetrahydrosulfate 6, aluminum trihydrogenate 5 solution respectively. Calculate the mass of metal deposited in each case. Number 4, during an electrolysis of molten sodium chloride, 2.3 grams of sodium was deposited on the cathode. Calculate the mass and volume of the chlorine gas liberated at the anode at STP. While number 5 is a metal of relative atomic mass of 64 was deposited by electrolysis. If 1.2 grams of the metal was deposited on the cathode, when 0.6 amperes flows for 1 hour 40 minutes, what is the charge on the cation of this metal? We have come to the end of the lesson, and when you evaluate yourself using the evaluation questions, you can now tell yourself whether you have actually learned how to calculate masses of electrodes or cathodes connected together in series. Thank you.